Example 1 here on integrating trig functions is taking a look at using results from memory. So here we're asked to integrate sec squared 3x. So sec squared 3x. Okay, and here we're integrating with respect to x. So here we know a basic result from memory is the integral of sec squared x with respect to x, which simply gives us tan x here. Okay, so that's tan x and alongside our constant of integration there. Okay, as we have no limits. So all we need to take into account here is the coefficient here of x is 3. Well, in that case then, the integral of sec squared 3x here, remember we divide by this coefficient. So in that case this becomes a third of tan 3x here. And again, we have no limits on the integral, so we just need our constant of integration there. Okay, and that gives us the solution to example 1. Example 2 here on integrating trig functions is taking a look at the double angle formulas. So here we just simply want to integrate sin x bracket sin x plus cos x. So the first thing I'm going to do here is just write it out with my integral symbol. We can write that as follows. So we've got sin x plus cos x. Now here, what I'm going to do is I'm going to take this sin x at the front and I'm going to times it by each term inside the bracket. So I'm going to do sin x times sin x, that will give me sin squared x. I'm going to do sin x times cos x, which will give me sin x cos x. So if we write that out then, this is the integral of sin squared x plus sin x cos x. Okay. And again, nothing changes here, we're just integrating with respect to x. Now at this stage here, this is where we can make use now of the double angle formulas. Okay, for sin squared x and sin x cos x. And in that case, using the double angle formulas then, this gives us the integral of a half of 1 minus cos 2x. Okay, so 1 minus cos 2x. Okay, and for sin x cos x, well, that's just simply a half, so that's a half of sin 2x. Okay, so a half of sin 2x. Don't forget our dx at the very end. And notice here we've got half of 1 minus cos 2x, and we've got a half here. We've got a half sin 2x. So now I can use linearity, and I can take this a half outside the integral. So in that case, what I get then is a half of the integral of 1 minus cos, so 1 minus cos 2x. Okay, so 1 minus cos 2x. And then don't forget, we just simply got sin 2x at the end. Okay. And now, this becomes straightforward trig integration. We just integrate each term as we go. We just leave the half outside and we'll just multiply through by the half at the very end. Okay, so we've still got the half outside here. Inside then, well, if I integrate 1 with respect to x, that would just give me x. So it just gives me x there. For minus cos 2x, if we integrate that with respect to x, that will give us minus a half sin 2x. So minus a half sin 2x. And finally then, for sin 2x, well, that's just going to give me minus a half cos 2x. So minus a half cos 2x. Okay. And then we'll close this bracket here. And don't forget our constant of integration. We have no limits on our integral, so we can't forget our plus c there. And to finish then, all we do is we take this a half here at the front of the bracket and times it by each term inside the bracket. So that's going to give me a half x. So I get a half x, or x over 2. I'm going to get minus a quarter sin 2x, minus 1 over 4 sin 2x. And finally, 1 over 2 times minus a half cos 2x. That would also give me minus 1 over 4. And then cos 2x there. Okay. And then finally, don't forget our plus c here, our constant of integration there. Okay, so to finish with, when we integrate this here, we obtain a half x minus 1 over 4 sine 2x minus 1 over 4 cos 2x plus c there. Okay, so that gives the solution there to example 2 for integrating trig functions.